This experiment investigates the PIC16F1887 MCU's ADC conversion capabilities, which is concentrated on its ADCC peripheral. This is accomplished by connecting an LED to the digital output pin and a potentiometer with a preset threshold of 1023 or 512. ADCC transforms the voltage from the potentiometer into a 10-bit digital value between 0 and 1023. This configuration also emphasizes the use of threshold-based logic in embedded systems, which convert analog inputs into binary outputs for applications such as actuator control or sensor monitoring. In the end, the experiment offers a fundamental comprehension of analog to digital interfaces, which is an essential ability for creating applications that combine output devices, microcontrollers, and sensors. Some code in the main.c. The ADC reads the voltage from the potential and transforms it into a digital value between 0 and 1023. The LED attached to A4 stays off if the value is less than or equal to 512, which is determined by a conditional statement. The LED goes on if the value is greater than or equal to 513. This reasoning shows how digital outputs can be controlled by analog signals according to thresholds. This is added into the main.c file, which utilizes the adcc underscore initialize function, and under it we can put in conditional statements that enable us to control the state of the LED using the potentiometer input.
So for the results, we can see here that in our circuit, we have a potentiometer that is connected in our RA0 or our input in ANX. And we have a LED that is connected to RA4. We can see here in the video that uh, when the potentiometer is at a certain point in its rotation or value, the LED lights up. So what's happening here is that uh, bi- uh, it is based on the code that uh, the the code is getting the value of the potentiometer, and when it is less than 512, the LED lights up. So if else it is not following the potentiometer value, that is not less than 512, or the value of the potentiometer is equal to 512 or more, the LED turns off.
The experiment demonstrated how the ADCC peripheral of the PIC16F18875 microcontroller unit may be used to process analog signals and use them for digital control. ADC operation became clearer to the participants. The usefulness of the ADC in connecting digital values uh, or analog inputs with digital outputs for practical uses like sensor monitoring, actuator control, was illustrated by the practical use of threshold based logic. The dependability of the setup was confirmed by the physical circuit, which was attached through an LED and potentiometer, which also verified the precision of ADC readings and their effect on the behavior of the LED. We recommend on expanding on additional sensors in future experiments to investigate more intricate analog to digital interfaces. Thank you for watching.